Okay, this video goes over Chapter 7, an overview using a PowerPoint, and we focus on sampling, and then we talk about something we lean on called the central limit theorem. So Chapter 7 is all about grabbing data from a population, and a population is big. We don't have the time or the resources to measure everything in a population. So what we want to do is grab a subset of that, which is a sample, and hopefully we do that well enough that the sample is representative of the population. So when we make decisions or infer something about the population, the sample helps us do that. So we'll focus on something called random sampling. We don't want to cherry pick. We don't want to introduce any bias. So hopefully we choose a sample where everything in the population is equally likely to be selected. And then after we've taken a sample, and let's say we calculate an average from that sample. Well, if we do that a whole bunch of times, we could actually draw a picture of what the distribution of these averages are. What is that going to look like? We need to talk about that. So random sampling is that if we have a population that's really big, so N is big. We have a lot of things in it, millions or billions of things. So if we think about the number of people and we did a census, we don't have the time to do a census every day. In fact, what do we do a census once every 10 years? So how do we make decisions about demographics if we don't have the time or the resources to measure everything? Well, what we do is hopefully we grab a sample. We come up with a much smaller subset that we can get done based on the time and resources that we have. But hopefully we don't cherry pick and we pick a sample that's representative of the population. This is kind of a picture of it. This is really big, and there's something about this that we're interested in knowing. We don't know. We want to know what the population mean is, or the standard deviation, or we want to know what the shape is. There's something about this we want to know, but we can't measure everything in it to determine what these are. So we grab a much smaller sample that we have time to do. So this is smaller than this, but hopefully we don't just pick from certain spots to make it convenient and bias. We want it to be equally likely. That's what the random part is. And once we have our sample, we have a series. So these are a much smaller set. Think of a sample of size 5. Well, what can we do with that? One of the things that we can do with it is calculate a sample average. And we can plot our samples, and that's really what descriptive stats is grabbing a data set and then calculating summary statistics or drawing pictures like a histogram from that. Later on, what we'll wind up doing is that we're going to make some assumptions. Well, we'll have a question about the population we're trying to study. We're going to lean on some assumptions, specifically the central limit theorem, and from that, we can have a hypothesis, which is a statement that we're trying to prove. We come up with a statistical test, and the test will give us an output. And from the output, we can infer something about the population. So this circular thing is we're always trying to solve or interested in studying this, but we don't have the time to measure everything, so we go down this path after we grab a sample. And just let me show you an example in Excel. Now, in this case, here's my population, and in this case I actually know what the population size is. I've got 12,574. Now assume that that's so big that we don't have the time to measure the IQ of everyone there, okay? But in this case I know what they are. So these are there. And if I take the average of that, right now I've got 100, okay? So normally I don't know what this is because this is too big to measure. Okay? So what do is I can randomly grab a sample. I can randomly grab a sample from this. And what I'm doing is hitting the function key 9. I'm hitting the function key 9. And what that does, it goes over here and it grabs a sample from that. And that's there's some little logic that's going, but I've got this set up, so I'm grabbing something. And in this case, my sample size is 10, which is much, much, much smaller than my population. But here's the deal. How close is the sample average to the sample mean? Does it represent it or not? And you can see that sometimes it's smaller, sometimes it's bigger, and that's actually quite a bit bigger. So you have to understand that when you sample, there is going to be some sampling error because we have a sample that is much smaller than this. If this is small, not always is this number going to look like this one. That's the challenge with sampling. And we need to have an appreciation of how much variability to expect in this so that we can make decisions or infer something about this. Okay, I'm going to do another video that will focus on the central limit theorem, but let's move on and finish the PowerPoint. There's different ways to sample to get random sampling, probability sampling. Don't worry about this, but sometimes you have to get data and you do this through convenience sampling. Okay, now we're moving to something called the central limit theorem. When I take a sample and if I calculate a sample average, and let's say I do this a whole bunch of times, and so now I've got a bunch of sample averages, and I build a histogram of those sample averages. What does the shape of that look like? And first of all, you can lean on the fact that when you do the sample, we've got the empirical rule that plus or minus 1 standard deviations, you'll get 68%, 95, and 99. But I want to focus on the central limit theorem. If we grab from a data set and we calculate a sample average, the distribution of those sample averages will look normal. This is the most important part of this, is that the distribution of the sample means will start looking normal. And we can lean on that when we start making inferences about the population. And what's cool is it doesn't matter what the underlying probability distribution is. If we take a sample and calculate the average, then the distribution of sample averages will always look normal. It'll get there quicker when you have a large sample size. Okay, the next video I will show you the central limit theorem in practice.